Hey Pre-Algebra, this is Mrs. Ratsburg. So we are going to start off our Looking for Pythagoras unit. How exciting. So this is just your cover page. Hopefully your name's on it. And so today we are starting investigation 1, where we are understanding what are called real numbers. And we're going to get more into what that word real means later. But today we are just going to be working through the problem 1.1, which is representing fractions and decimals. And by the end of this lesson, we want to be able to answer the focus question of how can you predict which fractions will be repeating or terminating decimals. So to get us started, it's just important if we all have common vocabulary in understanding of these 3 terms. So we're going to go ahead and just write down those and give some examples. If you're in class, you're going to be giving me examples. We're going to pause, but I'm going to just give certain examples here. Okay, so rational numbers. You've been dealing with these for a really long time, like your entire mathematical career since you started counting or identifying numbers. And rational numbers are numbers that can be written as a fraction. But also, more specifically, it's decimals that end... Oh, I'm sorry. I moved my iPad. Decimals that end or repeat. So, go ahead and pause and think through some examples. Okay, so hopefully you have some, but if not, here are some examples. So 2 is a rational number. Negative 4.5 is a rational number because that decimal ends. 3/5 is rational, it's a fraction. And 0.13 repeating is rational because it repeats. The 1/3 part repeats. All right, so specifically about the different kinds of decimals, there are 2 kinds. The first kind is a terminating decimal, and all that is a decimal that ends. So go ahead and come up with a couple of examples on your own. Okay, so now let's come up with, I'm going to tell you a couple more. So a couple more examples would be like 0.125, 0.5, that stops, right? And then also longer ones, but they stop. So 0.1, 2, 3, 4, 5, 6. Long decimal, but it stopped. And that's the important part. Okay, and then finally, a repeating decimal is a decimal with a pattern of a fixed number with a fixed number of digits that repeat forever, or forever if you want to, be mathematically accurate. So go ahead and think about some examples, and then I'm going to fill in some as well. Okay, so we can write repeating decimals in 2 ways. The first way is where we draw a line over what's repeating. So I could say like 0.3 and then draw a line above it. You might also see that, I'm going to write it underneath it as 0.33333, ... And that's where you're going to see it in this text, in this journal, because that's how CMP uses it. Another example of a repeating decimal would be like negative 0.18 line over the 1 and 8. So what that would mean, if we were to write it would be negative 0.18181818... And you have to see the ... or that repeating line, otherwise it is terminating and it stops. Unless it's on a calculator, then you have to make that assumption. But we'll talk more about that later. And then a final example would be like 4.86 repeating. And notice how only the 6 was repeating. So that would look like this. 4.8666666666. I'm saying 6 is way more than I'm writing. ... Okay, so there are decimals that neither terminate nor repeat. And so here are 2 examples of decimal numbers that have a pattern, but don't terminate and don't repeat. So we have 1.01001, 0.0001, 0.0001, blah, 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 blah. So go ahead and look at these two patterns or look at these two numbers and think, however you're learning right now, about what is this pattern and why is it not considered a repeating decimal. Okay, so I hope you had a great conversation about that. And so now we're going to just keep going. So you have also seen rational numbers such as 1/3 with decimal representations that are repeating decimals. You have also seen rational numbers such as 5/16 with decimal representations that are terminating decimals. Okay, so is the decimal representation for any rational number always a repeating or terminating decimal? Or can you represent some rational numbers as non-terminating, non-repeating decimals? So what do you think? Go ahead and give a second and think. All right, so hopefully, my hope is that you referred back to that wonderful definition we wrote at the very top of this page that said rational numbers are numbers that can be written as a fraction or decimals that end or repeat. So that means that rational numbers, rational numbers, hello, that was a weird glitch. Always, underline always a lot, are a repeating or terminating decimal. Always, there's no other options available. If the decimal terminates, it's rational. If it repeats, it's rational. If it doesn't do one of those things, then you can't call it rational. Okay, so what you're going to do now, you are allowed to grab your calculators, ideally Desmos, I would split screen I would split screen from this video, and then use a calculator to write each fraction as a decimal, then tell whether the decimal is terminating or repeating. And if the decimal is repeating, tell which decimals repeat. Okay, so go ahead and pause and do that now. All right, so hopefully you have done that, and I'm just going to do a quick little answer check, and I'm going to be lazy and just write T or R for time's sake. So I'm just writing them down. I'm not even saying them, but there is also an answer key on your home page that you should be able to access to see every single one of the answers. And I would, as I'm writing this, I'm just going to give you some advice. I would actually download that to Notability so you just have it. I'm really hoping that there are no mistakes. But if there are, it's my fault. I will own that. Okay, last one. Okay, so now that we've kind of seen some of these different examples, we are now going to try and really focus in on that focus question. Remember, our focus question was how can you predict which fractions will be repeating or terminating decimals? So hopefully the questions in part B will help reinforce or help you come to that realization. So let me just kind of walk you through what you're going to do. So answer the following questions. So we have this guy, Jose. He says that he knows that the decimal representation of a fraction, such as 3/8, will be a terminating decimal if he can scale up the denominator to make a power of 10. So that means like 3/8 equals something over 1,000. If he can do that, then it would be terminating. So what they want to know is what scale factor would Jose need to use to complete this equivalent statement listed below. So what they're asking is what can you multiply 8 by to get to 1,000? And that's that scale factor. Okay, so after you do that, I want you to make a conjecture, so like an estimated guess, a thoughtful idea, about how to predict whether a fraction will have a terminating decimal representation, like the examples we have up here in part A, where you notice that 1 through 5 were all terminating. So what about all those fractions, how could you predict that they were terminating? All right, then you're going to test out that conjecture, that estimated guess, that thoughtful thought you had on these fractions. So go ahead and pause and do that now. Okay, so hopefully you have at least made a conjecture, but I know sometimes you want to know answers. So just so you know, your scale factor here, it existed. It was 125. Okay, because 8 times 125 is 1,000. But I can't give you a conjecture because it was yours. So I'm not going to fill out questions 2 and 3. However, you probably, if you really don't know, go check the answer key. All right? Okay, so part D. Is it possible for a fraction to have a decimal equivalent that does not repeat and does not terminate? Explain your answer. So what do you think? Go ahead and pause and write down your thoughts. Okay, so hopefully what you realize is no, it's not. We already answered that. Like, we've answered it like 3 times now, I feel like. No, it is not possible. Whoops, it would help if I spelled right. It is not possible because you can only write fractions if the decimals terminate or repeat. Now, honestly, like, based on this conjecture, hopefully that gives you a reasonable thought. You'll come, if you really have no idea and you're like, I just type it in the calculator and I find out, that's fine. Like, it really is fine. Like, it's not a big deal. As you interact with more and more division problems, ideally with smaller divisors, so that second number you divide by, you might start realizing, well, a number that has this feature or factor or whatever, my answer always repeats. Or, this one ends. I wonder why. And you might come to it on your own. And usually I don't like just telling you things, but hopefully you've made a realization. If not, I'm just going to tell you a realization and hopefully it will come true eventually. But so how can you predict which fractions will be repeating or terminating decimals? Okay, so a fraction, and I'm going to go out of this box because I'm way bigger in notability. So a fraction will have a terminating decimal. The terminating decimal if the denominator, and that's the bottom number of a fraction, only has factors of 2 and 5. So let's just go up for a second. So based on that, the only one of these on question 3, 4 7s, 5 6, 25 12ths, and 19 20ths, the only one of these that could potentially not repeat or that would terminate would be this 19 20ths, because the factors, if we did a factor tree of 20, that'd be like 4 times 5. But then if we did a prime factor tree, 4 times 4 is really 2. 4 is 2 times 2, and so that's only factors of 2 and 5, because 2 times 2 times 5 is 20. Okay, and then a fraction will be will repeat, or will have a repeating decimal if it does not meet that requirement. Because think about it. I shouldn't talk about other things while I'm writing. Requirement. Because think about it. If we have like 1/3 repeats, it's 0.3 repeating. Then 4th, that terminates because it's 2 times 2. 5th, that terminates, it's 5. 6 is 2 times 3. 1 over 6 is 1.6666666 repeating forever. 1/7 is this dreadful fraction that I don't know because it repeats and it's a really long repetition pattern. So I don't know that, nor do I ever expect any of you to know that. 1/8 is 2 times 2 times 2 or 2 times 4, so that's going to terminate. 1/9, well, 9 is 3 times 3, so that's not going to be any good. So that's going to repeat forever. And 10 is 2 times 5. So you'll come to realize these patterns, but also in the grand scheme of things, just know that the biggest thing is know that fractions will either have a terminating decimal or a repeating decimal. That's like the gist. All right, so at this point you are going to do your daily practice. Please let your math teacher know if you have any questions over that, and have a great day. Bye-bye.